This is California Weather, a pre-calculus/trig project by Justin Sommers. The problem. To the right is a set of data showing the average temperatures each month for the year 2016. You will A. make the given data more usable, and B. predict the average temperature in June of 2018. For part A, plot the data, create an equation, and graph the equation. For part B, find the average temperature in June 2018 using any method. This is our data. As we can see, its low point is 57 and its high of 74. This is January, December, June, etc. Part A. This is the data and scatter plot. We can see that the data forms what seems to be a curve. From what we know about weather, we know this is a sinusoidal relationship and not a parabola, so it's more like that, not just that. We can use that to derive the equation. We want an equation in sinusoidal standard form to illustrate the data. Y equals a sin bx minus c plus d. Data is here as a flower. A is the amplitude, or the absolute distance from the median of the data. Median, as we said, the 74 plus 57 divided by 2, 65.5. So the average of the entire year is 65.5 degrees, and it varies about 8.5 degrees. So 74 minus 65.5 is 8.5. Amplitude is B equals the period. B equals 2 pi divided by the 12-month interval. Months, B equals pi divided by 6. D, the median, we calculated that here, 65.5. C is the phase shift. We want to know the new starting point at our starting point, 157. So we plug that into what we have. 57 equals 8.5 for A, pi divided by 6, and we put our x minus c into parentheses, and 1 minus c, because x 1 and 57 is y, plus 65.5 d, and c, when solved, equals 4. And if we plug it at 4 back into c, and we solve this out to get back into this standard form, c equals 2 pi divided by 3. Y equals 8.5 sin, in parentheses, pi divided by 6 times x minus 2 pi divided by 3, and parentheses, plus 65.5. This is the graph of the equation. See, as it is very similar to what we saw before. This point here is 1,57, our low point and our new starting point for the 12-month interval. This is our equation, new data. So we know that this is a well-fit line. Varies only about 5 degrees. It's a pretty good line. Part B. June is the 6th month of the year. Therefore, we can look at our data and see that 6 equals 72 degrees. Our line approximates it at 72.8. This is very similar. That is the actual data, 72.8. So then we move from 6, which was around here, to 30. Both of these are June, so I will now explain. On the previous slide, we see that when x equals 6 and when x equals 30, then y equals 72.8. Simple math tells us that in 2018, 2 years later, or if we go back 2 intervals later, 2 years later, 30 months have passed since the beginning of 2016, or 0. This is a reasonable approximation to make with the given data and extrapolation. The actual recorded average for June 2018 was 73 degrees. It is reasonable to say that within a degree of error of about 5 degrees, this graph is accurate. We can also get 72.861 from algebra. We just have to plug in x equals 30 for x, simplify 72.8. If you wanted to be very rough, then you could find the sixth dot, 1, 2, 3, 4, 5, 6, and say that is your answer. 72 degrees. California has a stable climate year-round, doesn't vary too much, so 72, and as we saw a couple slides ago, the actual recording was 73 degrees. If we calculate an error of about 5 degrees, then through reasoning, this is a reasonable answer. Those are my sources. Thank you.